Hello everyone, I'm Menaka Bhaskar Pillai. My session is about using Azure DevOps to deploy Azure function to Azure Kubernetes. This is a title I'm going to discuss on today's Serverless Days ANZ 2020. I'm so excited to deliver this topic. Before that, let me introduce myself. I'm Menaka Bhaskar Pillai, working as an associate software engineer at Accenture. I'm Azure and .NET certified professional. For any doubts and clarification, you can reach me out via my Twitter, LinkedIn, or via my email address. So let's jump into our topic. What is Kubernetes? Before going with very basic stuffs like what is Kubernetes, what is Azure function, I just want to make sure of some of the important topics that may helpful for better understanding of today's title. So what is Kubernetes? Kubernetes is an open source system for automating the deployment, scaling and management of the containerized application. If it comes to a microservice application, we need something to deploy our containerized apps in our Azure. So there is something called Azure Kubernetes that supports the deployment of containerized application into our Azure. So that there comes the Kubernetes into an action. So the next slide is what is Kira. If you are deploying a normal web app, it is very easy to perform the deployment activity. Either it is a microservice application that is a containerized app. You can simply build an image and you can publish an artifact and you can deploy that into your Azure Kubernetes service. But if it comes to Azure function app, you want to deploy that in your Azure Kubernetes. You want something to assist your deployment for adjusting your auto scaling property, because auto scaling is a main thing that you need to consider while you are deploying your Azure function app in Azure Kubernetes. This is not yet supported in previous things, so that is the reason deployment of Azure function app in Azure Kubernetes faces lot of difficulties. To overcome this difficulty, Kira comes into an action. The full form of Kira is Kubernetes based event driven autoscaler. It is a single purpose and lightweight component that can be added into your any of our Kubernetes cluster, so it supports the auto scaling property. So we have Kira, so we don't need to fear for deploying our Azure function app into Azure Kubernetes service. So before we are exploring a lot about our project, we need to understand some of the basic features of Kira, so that may help us to investigate further knowledge of Azure function. So Kira is nothing but it's an event driven, so it is used to intelligently scale your event driven application. So it have a built-in autoscaler, out of box scalers for various vendors, database, messaging system, telemetry system and more. It has multiple workload type, so it supports the variety of workloads such as deployments and even your batch jobs. So it is a vendor agnostic, so wherever the word agnostic comes, it means it supports all. So it supports multiple vendors also. It's a Azure function support, so it can run and scale your Azure function on Kubernetes in production workloads. So this is a main features of Kira. So it makes our Azure function to run our Kubernetes cluster, so it makes it to auto scale whenever you have more requests. It increases your count of pods whenever you don't have any request or your application is idle, it just reduces your pods. So auto scaling comes into action, so it's very easy to deploy our Azure function to Azure Kubernetes. So event source to scale, we need some event or source so that triggers our scaling, because based on that request only we can tell our application is scalable or not. So there are some of the sources to scale. Here I am using Azure Storage in queue. So other than that, there is a blob storage, monitor and event hub, service bus and GCP. In AWS, SQS and more are available. So based on your event, you can able to scale your application. So what today, like deploying on your AZ function through Kubernetes. This is our today's title. I'm not going to explain everything from my deployment scratch to how it is working in my Azure Kubernetes end. So let me just short out every steps I'm going to do in project, so that may helpful for better understanding instead of showing the final output, because in a demonstration I'm directly showing the final output. I'm simply creating a Azure storage account, that is a queue storage account, to save the message in the queue. So this act as my event source. So after that, I'm using the Azure Function Core tools to read the data from the storage queue. So based on the data I'm reading from the storage queue, I'm getting my pods, that auto scaling property happening via my KIDA in my Azure Function app. I need an image to deploy my function app to Azure Kubernetes Service. If you have a Docker, it's very well and good. If you don't have a Docker, just go with Azure Container Registry to get your image ID and other thing that you need to deploy your application to Kubernetes. I'm just having my Kubernetes cluster to manage my node and deployment.yaml file which has the configuration to deploy into the Kubernetes. As well as I need having my DevOps project as my source code controller and CI/CD pipeline where I'm doing the two action. I'm building and deploying the Docker image of Azure function using the CI/CD pipeline. After that, I'm deploying my Docker image in Kubernetes using a Azure Container Instance. So this is a complete step and complete thing you need to do to deploy or run your Azure function app in Azure Kubernetes Service with Azure DevOps. Since doing a step from the scratch to the end, it will take long time. Even in a final demo, it is not possible to show everything from the scratch. I'm just taking some of the important concept how application works. So if you come here, I'm just having my VM on one of the tab. So I just start my VM. This is where you actually need to start, because every time you are doing something, a VM is getting created, and anything you want to work, you need to just start your VM to perform your action. Once after that, here it is where my registry. This is where I am doing my Docker image, that is image creation. I will get my details about the image that I am going to deploy in Kubernetes via this. If you have a Docker, you can enable the Docker and you can perform the action. If you don't have Docker that being supported in your Windows because of professional and personal use, you can use container registry to create your image. So here I'm having the versioning control, so it will list out based on my deployment activity. Once after I'm registering and I'm getting my image ID and other thing, those kind of things will be available here, so you can check here and you can get the details that you need. Once it is done, I'm going to manage my message property. This message property act as a event source based on the image message property. I'm getting my all the VM, all the ports that need to support my action, that is auto scaling property. So I'm just adding my message. I already deployed and my application via my DevOps into the Kubernetes cluster. So I'm doing the final activity, how it's works. So this is a message I just want to add. So once I am adding my message, so my message is once added, I'm just navigating to my pods. This is where this is a Kubernetes cluster. I'm just navigating to pod session. I'm choosing the default as my namespace and then I'm refreshing it. It will take some time to display your pods based on your request. Go back to your message and then just refresh it again. I think it's loaded. Yeah, it's getting created. As soon as it created, just take one of the pod and I'm just copying this. I'm already have the inbuilt PowerShell script that I need to run. So I'm just replacing this to read the message from there. So let's run this PowerShell script in our Azure CLI, Azure PowerShell. So I'm just navigating here. Sorry. I think it's not yet pasted. So again I'm just choosing this, copying this, I'm just running. Okay, let's give paste and then we'll run and see. So see, the message is getting read from my Kubernetes cluster, and this is how my pods being created, and it automatically terminating based on the access. Now go again to your workloads. See, this is how my pods are getting created and it getting terminated. So whenever I just request a message or any event source, I'm getting the auto scaling property pods are created. So now I don't need anything. My application is idle. This is my application. I'm just dequeuing. I have no message here. So you just clear the queue. So now I have no more request from the event source. Now I'm going back to my pods. It will take some time to terminate everything. So just refresh it again. It's getting terminating. So this is how exactly Kida works, auto scaling property of your Azure Function app. Since I already deployed my Azure Function app in my Azure Kubernetes, I'm performing some event source as my trigger, so it will act as a source. Whenever I'm giving some external source, it is auto generating or auto creating the pods based on the request. Once I have no source, I make my application to idle. So at that cases, it is terminating the available pods. This is how Azure Function apps works with Azure Kubernetes service along with Kida. So this is all about today's session. So I hope this will helpful to many of the people who being working on DevOps end as well as in a serverless end. And this is all about my session. Thank you. We'll meet you soon.